This video is about ocean tides. I have two pictures here from coastlines where the tides are evident because of the rock formations. In the left photo here, you can see that there's a pool. It's actually called a tidal pool of water. And when the tide is high, this pool might be flooded and you wouldn't even be able to maybe see the rocks. The rocks might be completely submerged. But then when the tide is low, the rocks become exposed and little pools of water are left behind, and people like to go and look for sea stars and sea urchins and all kinds of little tidal pool critters. Here are the Unit 8A learning outcomes. Go ahead and pause the video and write them down. The learning outcome that this video covers is number 1, describing Earth's tides. Here's a fun set of photos. This is from the Bay of Fundy in Newfoundland, Canada, and this location has the claim to fame of having the largest tidal range, the biggest difference between high tide and low tide. So here you see two boats that are at high tide, and this is the bay back here. It does connect to the ocean. And 6 hours later, this is low tide. So let me go back. Look at this red instrument here. High tide, there's that red instrument, low tide. And then over here there's a yellow container. I'm not sure if it's a trash container or something, and there you can see it. So this is a pretty extreme example of tides. So what are tides? Well, tides are waves. They're actually water waves caused by the gravitational force exerted upon the Earth. And that force is not only exerted by the moon, but also the sun. A lot of people think of just the moon as dictating the tides. So we'll talk about both of those. So here's a little cartoon of the Earth looking down on the North Pole. And then we have the moon. So the Earth pulls the moon towards it gravitationally, and the moon pulls the Earth towards it gravitationally, and they're in balance. Now, because both the Earth and the moon are solid objects, you don't notice that the tides are pulling on them. However, if we look a little more closely at the moon pulling on the Earth, we know that the Earth also has water. And water can be pulled to change shape depending on the container, or in this case, depending on the force of gravity. So the moon pulls the water, and it creates a bulge in the water towards the moon. And this is what we call a high tide. Now, I'm exaggerating this quite a bit in this cartoon here, for reasons that you really don't want me to go into, but you're welcome to check out in your textbook. There is an equal and opposite high tide created on the other side of the Earth from the position of the moon. So we actually have two high tides, one on the side of the Earth that's facing the moon and one on the opposite side. We thus also have two low tides, so that as the Earth spins, if you were located right over here, you have a high tide, then a low tide, then a high tide, then a low tide, then a high tide, and that would be a 24-hour change. So here you are on the beach with your beach umbrella, and it's low tide. Let's say it's 11 o'clock in the morning. And you hang out at the beach for 6 hours until 5 o'clock in the evening. So you rotate with the Earth, and here you are 6 hours later, and now you have rotated into the high tide region. This picture is a little bit better, showing the water being bulged out from the Earth. But again, this is much more than reality. At this scale, you wouldn't even see the tidal water bulge because it would be so thin. So it is exaggerated. But one thing that's interesting here is it illustrates how even though there are two high tides a day in general, they're not always the same height. So the moon is not actually over the equator. And that varies over time, and we're not going to go into that right now. But in this picture especially, you can see the moon is here over some southern latitude. So there's a high tide bulge here, and then there's a mirror image high tide bulge over here. This time we're looking at the side of the Earth instead of from the North Pole. It doesn't really matter. But as you move around the Earth, as you spin with the axis, you're going to pass through a higher high tide, then a low tide, then a high tide that's not quite as high as the previous one, then another low tide, and then back. So that's a little complication that you'll see show up in a few slides from now. Okay, so let's talk about the sun. So we have the Earth, the moon, This time I'm going to make the water just this blue line that's bulging on either side. In comes the sun, and then I will show the sun's effect on the water in red, and that's, in this case, pulling it in the same direction as the moon. So when the moon and the sun and the earth are all in a straight line, you get the lunar tide, the solar tide working together to make a very, very high tide. So the sun and the moon both exert a tidal force. The moon's force is actually about 2 times as strong as the sun's because the moon is so close. Of course, if the sun is much larger, so if the sun and the moon were equidistant from the earth, then the sun would win for sure. But because the sun's so far away, the moon has more of an effect on the pull of the water. And by the way, it isn't just the water that's pulled. The atmosphere is pulled towards the sun and the moon. Even the solid earth is pulled, but that one isn't as obvious. Okay, so we're going to look at a couple different types of tides depending on the moon. So let's look at this picture here, which is similar to the one I just showed you. Forget this full moon over here for the moment. So we have the earth, we have the sun, and in this particular position, this is the new moon phase. Both the moon and the sun are working together, so we have a very high tide, and we have a very low tide over here. This is called a spring tide, and this is when we have the maximum range of high to low. So we have the lowest low tide, the highest high tide. This occurs when the earth, moon, and sun are in a straight line, as I mentioned, and sometimes it's said that the tides are in union. This occurs during the new moon, but also during the full moon, because remember, if the full moon is pulling on the earth here, there's an equal and opposite bulge of water on the other side. So every 2 weeks, we have a spring tide. Every 2 weeks, we have a neap tide, and this corresponds to the first quarter and the third quarter moons. So let's look at just this one up here. Here's the first quarter moon pulling Earth's water up in this diagram. The sun is pulling it to the right, so they're kind of working at 90 degrees to each other. And as a result, we get the smallest tidal range. We get the highest low, which is over here, and we get the lowest high, which is over here. The term neap tide is believed to have come from the idea that it was nipped. So the earth, moon, and sun are in what we call the quarter positions, and these tides are offsetting each other. This corresponds to the first quarter moon and the third quarter moon. These are some diagrams from your textbook. I just wanted to show these to you so you are familiar with them. They are actually a bit clearer than what I just showed you. They're simpler. So in the spring tide scenario, we have the moon, which is pulling, and the light blue is the lunar tide. The sun is pulling, and the dark blue is the solar tide. So during the spring tides, they're additive. And we have very high highs and very low lows. In the neap tides, we have the solar tide shown in dark blue, the lunar tide in light blue, and you can see that, again, the high tide is dictated by the moon. Remember, these are very exaggerated, that the water on the earth does not extend that far into space. So what I just told you should make you think that every day you get 2 high tides and 2 low tides, and sometimes they might not be at exactly the same level. But there are actually other patterns because there are other factors. The shape of the coastline matters, the configuration of the ocean basin, the depth to the ocean basin, how quickly it gets shallow or deep as you go offshore. And this results in 3 types of tidal patterns: diurnal, semi-diurnal, and mixed. So let's take a look at those. In the center, we see a map showing these 3 kinds of tidal patterns and where they are found. The other 3 images here are graphs showing tidal highs and lows over a 48-hour time period. Let's start by looking at the upper right here, this one called semi-diurnal. So along the x-axis we have time. We have 0, 12, 24 hours, that's 1 day. 12, 24, that's 2 days. And then here we have the height of the tide, with the 0 being some sort of established 0 point. So if we start over at the 0, we have a low tide, a high tide, a low tide, a high tide. So 2 of each in 24 hours, and then we go back to low, high again. This is the semi-diurnal tidal pattern. Over here on the left, we have the mixed tidal pattern, which also has 2 highs and 2 lows every 24 hours, but these are of different height. So here we have a high tide, a low tide. Then we have a not so high tide, a not so low tide in 24 hours. And then we go back to that same pattern, very high, very low, sort of high, sort of low. And you can see on the map that mixed is quite common, that's the green, the semi-diurnal is the yellow. We also have a third kind called diurnal, and that's shown down here, where we only have one high and one low every 24 hours. And those types of tidal patterns are common in enclosed regions such as the Gulf of Mexico. So this is a region that has land on most sides of it. So as the tides go in and out, they are affected by the geometry of that region, and they wind up producing the diurnal tidal pattern. So in summary, we have a diurnal pattern, one high and one low every 24 hours. Semi-diurnal, two highs and two lows every 24 hours at the same height. And then the mixed, two highs and two lows every 24 hours at different heights. So now we're going to put this all together and look at a month of tidal patterns. Along the x-axis here, I have days, so 30 days. And then I have 1, 2, 3, 4, 5, 6 different locations where they're showing you the tide variations throughout the month. They're also indicating when the neap and spring tides are occurring in the diagram. Now, the one here that I think is the simplest to understand is the one from China. So when we have the neap tide, the third quarter moon, that's when we have that smallest tidal range, the lowest high and the highest low. And then as time goes by and we get closer and closer to the new moon, the tidal range grows until a maximum, and then it goes back down again to the neap, and then it goes back up again to the next spring, etc. The other 5 cities have similar patterns, but they're not nearly as clear, and the maximums don't always seem to coincide with the new moon and the full moon. Especially Los Angeles here has something strange going on at this new moon, but again, that has to do with the shape of the ocean basin and the geometry of the seafloor. But these are generally what patterns would look like throughout a month. Okay, that was a quick overview of tides. And tides are a type of wave, as I mentioned at the very beginning, and the next video will talk about waves.